Hello everyone, welcome to Programming Knowledge. So I again welcome you all to yet another tutorial at Programming Knowledge. So let's today discuss the problem that is staircase problem. This is a very interesting problem. You can like uh, yeah, I'll copy this description. Yes. So let's solve the staircase problem today. This is a dynamic programming approach. Title is staircase problem. Description is two-step staircase problem or three-step staircase problem. In these problem, a base case is taken. Okay, first I'll take a suppose just for example, we discuss for two steps. Let's discuss for two steps. Okay. You can either take like you have the probability that you can take one step or two steps at a time. This is your choice. So in how many ways you can reach the nth step. Okay, so let's remove this. You can get to see the description that we are discussing two step staircase problem and three steps staircase problem. Okay, so for two steps staircase problem, you can take one step or two steps at a time. You can take one step or two steps at a time. In how many ways you can reach the n step? Okay, first we'll take the base cases. Base cases, that is, uh, to take the zeroth step, there is only one case I've also written here. To take the zeroth step, uh, uh, like in these problems, a base case is taken where there exists only one way to take zero steps, that is to take a no step. Like if you want to take the zeroth step, the how many ways you can take the zeroth step. The only base case is to take no step. So take no step. So how many ways you can reach the zeroth step? Uh, that is to take no step. So this concludes number of ways is equal to one. Okay. For one step, you can take you can take only one step. Okay, and uh, for zero step I explained you to take no step, so number of ways equal to one. For one step you can take only one step, so number of ways is equal to one. For two steps, what you can do, uh, you can take you can take either 1 plus 1 or 2 plus 2 only. So you can take either 1 plus 1, or you can take one step, then again one step, or either you can take a step with two steps. So like a step to the length 2, so number of ways is equal to 2. So you initialize the DP array of zero based indexing. I'll write zero based indexing 1 comma 1 comma 2. Okay. uh, like in the same way, you can approach this problem for three steps. So I'll explain. So three step staircase problem, you can take one step, two steps, or three steps at a time. In how many ways you can reach the nth step? Base case, for zero steps, there is only one way, to take no step. Only one way, only one way, that is to take no step. Okay, so only one sorry only one way, that is to take no step. I'll paste the same here. So number of ways equal to one. First step you can take only one step, so number of ways equal to one. two steps, you can take either 1 plus 1 or 2, that is number of ways is equal to 2. uh, uh, Now I'll define the case for 3 steps. Then for 3 steps, what you can do, you can take either 1 plus 1, 1 plus 2, 2 plus 1, and 3. So number of ways is equal to 4. So yeah, number of ways is equal to 4, and in the same way number of ways is equal to 4. So here I've defined number of ways equal to 4. How come? Like you can either take 1 plus 1 step, 1 plus 2, 2 plus 1, or 3 steps. So number of ways equal to 4. So with zero based indexing, for 3 staircase problem, this becomes this. Okay. Now uh, what you can do, let's try to code this algorithm. Okay, yes, perfectly fine. So let's like now what you can do, we can code this algorithm for both the cases. So for count ways, 2 steps. So this is a dynamic programming approach. So dp is equal to 0 star n plus 1. This is for count ways 2 steps, and in the same way we can define for count count ways 3 steps. 3 steps. So what we can do, in this we can initialize for 2 steps, we can initialize the base cases like I told you. dp of 0 is equal to 1, dp of 1 is equal to 1, and dp of 2 is equal to 2. Like in this way we can initialize the same for this. dp of 0 is dp of 0 is equal to 1, dp of 1 is equal to 1, dp of 2 is equal to 2, and dp of 3 is equal to 4. So ideology, you can see, like for both of them, for see the last index, that dp of 2 is a summation of 0 plus 1, and in this dp of 3 is a summation of previous 3. Okay, so you can code the algorithm like this. So for I in range n plus 1, if uh, if uh, you can see, like you've already computed for 0, 1, 2. Now you can only compute for 3 in this case. Like you've already computed for 0, 1, 2. Now you can compute for 3. Then dp of I is equal to dp. You can make a guess what we are going to do here. dp of I minus 1 plus dp of I minus 2. This is very much similar to Fibonacci problem. So this is known as Fibonacci. Not exactly Fibonacci, because Fibonacci start from 0, 1, 1, but we are starting from 1 and 1. So but if we take the base case as 1 and 1, the summation goes like 2. 1 plus 1 is equal to 2, then 2 plus 1 is equal to 3, like this. So a kind of a Fibonacci problem, a kind of a Fibonacci problem. So this is a kind of a Fibonacci problem with start initial 1 comma 1. So yeah, perfectly fine. So this is how we can compute, and then we can return dp, or else you can return any index you want, or you can also return dp of n. This is a kind of like you can say that this is a kind of a Fibonacci problem. Fibo, yeah, Fibonacci problem, because in this we take 3 variables, a kind of a Fibonacci problem with initial 1 comma 1 comma 2. So because this term is calculated by previous 3, and in this one this term is calculated by previous 2. Then for you have already calculated for since you have already calculated for 3, so you can calculate it for remaining ones. So dp of 4 comma n plus 1 to dp of I minus 1 to I minus 2 plus dp of I minus 3. So let's compile a program. Yeah, it compiles perfectly. So you can calculate it for any step using this formula. So kind of a Fibonacci problem with initial 1 comma 1 comma 2. So then you get in this 1 plus 1 is equal to 2, and in this you get 1 plus 1 plus 2 is equal to 4, and I've explained the base cases here. So thank you guys for watching this tutorial. I'll catch you in the next tutorial. Thank you for watching.